Hello, my name is Giacomo Bernini and I am R&D Operations Leader at Nextworks. In this presentation, I will talk about how MLOps is becoming an essential enabler for AI-native 6G networks, reviewing relevant standards, and introducing challenges and solutions towards distributed and decentralized AI/ML workloads management, with specific focus on the solution delivered by the Android 6G project. So, we know that with 6G, the next generation networks are expected to be more and more pervasive and also include and integrate different types of technologies and network domains. This brings the need of introducing, even more than in 5G, full automation in how 6G network and services are managed and operated. Given the variety of network technology and domains to be integrated, there is the possibility to exploit huge amounts of data that can be collected at different layers and source points. And we can have even more that what 5G started to define and offer a pervasive deployment of AI/ML capabilities and AI/ML services inside the network across a continuum of edge and cloud computing resources. There are a few technology enablers that have been defined since the beginning of the 6G journey as enablers for introducing this automation concept and integrating those capabilities into the 6G architecture blueprint, as it has been initially also defined in the XX2 project, the flagship initiative for the 6G network blueprint definitions. These are shown in the slide and include MLOps as the technology to streamline the management of the machine learning model lifecycle, applying a DevOps approach to the ML domain. DataOps as a set of crucial data management and manipulation services for managing in an efficient way high volumes of data expected in 6G networks. And finally, AI as a service, which is pretty much linked with the two above, as it enables AI and data capabilities to be exposed in the form of services towards the vertical application layer. But why MLOps is needed? There is a nice paper from Google that gives very good insight on this. As you can also see from the figure, the machine learning code is the smallest fraction of the complexity of an overall ML-based system. Most of the complexity lies in all of the other aspects of an AI-based system. The management and operation of data pipelines, how to manage models, how to train them, how to analyze the outputs of a model, how to deploy and serve a model, and how to monitor the performance of a model in order to avoid drifts and to trigger some kind of adaptation of the model itself. So it becomes clear that without techniques that try to put everything together beyond the actual development phase of the machine learning model, all these ML-based systems risk an accumulation of technical debt with the reliability of the overall system that can be also compromised. That is why, indeed, MLOps is introduced. This is not a new term or a new technology. In principle. It relates to the application of the DevOps concept to the ML domain, trying to introduce a closed-loop concept through automated pipelines that automate the whole life cycle of a machine learning model, from data analysis to development of the model, to its engineering and development, to testing as part of the training, and then at the end, deployment in pre-production and production. Continuously testing and evaluating the model in terms of performance, risk detection, with the aim of analyzing whether there is a need of either retraining or even re-engineering the entire model. So basically, MLOps bridges the gap that exists between experimenting with or developing a machine learning model in a notebook-style approach and the production-grade deployment of ML services. It is indeed a set of techniques, tasks and procedures which, if automated, really help in closing this gap, adopting the classical DevOps paradigm that is well used and adopted in the IT and application development domains. There is also a wide standards landscape around MLOps, not natively conceived them as MLOps per se, but in the scope of the 5G network architecture definition. Indeed, in 3GPP, there is a consistent amount of work that started with release 18, that continued in release 19, and also release 20 concerning the application of MLOps capabilities to the lifecycle management of models in the management and orchestration domain, and also defining distributed workflows and AI deployment models across run and call domains. Other work items relate to the exposure to a service-based approach of AI/ML capabilities towards the vertical application layers, following the standard GPP service enablement approach. There is also, in the context of ORAN, a set of activities concerning the definition of AI/ML workflow services in the context of the non-real-time RIC for the intelligent control of Open RAN resources. And this defines procedures to operationalize the use of AI capabilities inside the RAN. This is pretty much linked also with the work carried out as part of the AI/RAN Alliance which is a recent industry initiative which goes together with ORAN in defining principles for integrating AI capabilities into the RAN. It focuses on different but let's say similar aspects, including AI for RAN, AI and RAN, and AI on RAN that allow AI to be used and deployed as part of RAN networks, covering the specific needs of the RAN or leveraging RAN networks function to host application level AI services. All of these show that there is indeed a consistent work also from the standardization perspective in trying to introduce YAML management aspects as part of the next generation network definition. But also on the open source side, there is a very wide landscape of tools and solutions available. There is an interesting landscape provided by the Linux Foundation in terms of tools and frameworks available on AI and data aspects, which shows the very wide ecosystem of tools useful for MLOps. There are several projects indeed that are available, organized in different categories related to machine learning, reinforcement learning, data management, data operations, explainable AI, and so on. And for each of them, there are subcategories that allow to identify those that are frameworks, those that are tools, programming languages, or libraries. This is something that, at least in the case of the Android 6G project, we found very useful for setting the ground on the state-of-the-art of available tools that can be, let's say, used and reused to build a more comprehensive MLOps solution. And specifically, indeed, in the project in Android 6G, we targeted a few of them, which we adopted and integrated for machine learning cataloging, training and tracking, and pipeline management, which together provide a common way to model and manage machine learning models irrespectively of the ML framework that they use in order to foster interoperability. So basically, to stress that also in the open source landscape, there is a huge set of tools already providing a lot of capabilities to realize production-grade MLOps solutions. So, focusing more on the Android 6G approach, in the project, we delivered an ML framework that implements the crowdsourcing AI concept, which is very well explained also in another online tutorial from Professor Carla Fabiana Chiasserini. And specifically in the AML framework realized in the project, we focus on the AML operations platform capable of managing and orchestrating the training, storing, sharing, and usage of AML models across the 6G compute continuum. Indeed, the framework coordinates the provisioning and execution of AI training and inference functions as cloud-native functions supporting heterogeneous training schemes and ML model technologies, and model service functionalities as a service. The framework is therefore capable to coordinate heterogeneous AI/ML tasks on top of distributed resources across the continuum, distributing indeed AI/ML workloads in different locations in the network depending on task requirements and resource constraints, such as available computing resources, energy consumption, and others. Basically, the AML framework architecture developed in Android 6G is built around the AML orchestrator, which serves as the central component to realize the crowdsourcing AI concept and executes the various AML task requests, including model metadata query, model and pipeline onboarding, model selection, and model training and deployment. The ML model selection component provides AI-based tools for energy-efficient model selection and real-time model adaptation to customize models to tailored operational conditions. For example, this can be for resource-constrained model inference at the extreme edge. The ML orchestrator engine component determines the specific custom logic and the AI-based coordination approach for each requested AML task, and the AML catalog is the access point for the tracking of model training and published model versions. And finally, the AML pipeline manager manages the deployment of training and runtime AML functions defined through pipelines using a service-based approach, and it practically provides the MLOps capabilities within the Android 6G AML framework. Having a deeper look at how the MLOps solution has been implemented in Android 6G, it basically consists of a common ML management layer that abstracts the capabilities and functionalities of specific AML tools for pipeline management, model catalog, and model storage. In particular, the developed solution integrates Prefect, MLflow, and C-with-FS as open source tools and build and expose on top of them a set of AML services that can be invoked by external users through custom REST APIs. First, it supports model training services through PyTorch, TensorFlow, scikit-learn predefined pipelines. And it also offers a custom pipeline framework supported to integrate and support any type of machine learning framework and model. So there is real flexibility in supporting different type of models and technologies. The model catalog implements and exposes custom model metadata and provides model versioning and comparison functionalities, as well as a model query engine. On the other hand, the ML models can be deployed leveraging on Torch Serve and Docker ML server engines, and in addition, a custom inference engine is also available to expose machine learning model serving functionalities through REST APIs, so that models can indeed invoked dynamically by external components within the Android 6G architecture. The Android 6G solution also integrates and supports federated learning schemes, providing unified federated learning management capabilities for dynamic federation setup and dynamic execution of experiments over existing federations. And finally, the solution also provides infrastructure management capabilities, supporting the dynamic management of prefect training workers and inference servers in the compute continuum, natively supporting containerized deployments on top of Kubernetes infrastructures. The .6G MLOps solution has been also extensively validated within the project proof of concept activities and has been also demonstrated in several events. In particular, I'd like to highlight a couple of them. Specifically, the solution has been integral part of the ETSI ZSM proof of concept activity on AI-enabled predictive closed loops that the Android 6G project has successfully completed, supporting in this case the automated training, deployment, and exposure of AI/ML models on top of Kubernetes-based edge cloud continuum infrastructures in the context of a collaborative robot application scenario executed in a production-grade 5G standalone testbed provided by Orange Romania. Moreover, additional capabilities for the MLOps solution have been also specifically demonstrated at the UCNC 2025 conference, showcasing in that occasion the automated management of a distributed federated learning solution at the edge over non-terrestrial networks, basically showcasing the automation of both the deployment of federations and the execution of federated learning experiments in support of automated railway operations. This was linked to the POC 2A of the Android 6G project. So basically, in conclusion, we have seen that AI MLOps is a crucial and highly relevant technology enabler for the development of AI native 6G networks. There exist solid reference baselines in the standardization and open source landscapes, even if they bring some level of fragmentation. And in this context, Android 6G made already significant progress and implemented and validated an innovative solution that actually helped in addressing some of the key challenges to fully adopt AI MLOps in support of AI native 6G networks. Some of these are the management and coordination of distributed and decentralized AI/ML tasks, the integration of AI/ML workloads at the stream edge, and also the support of sustainable AI processes. However, we know that a few technical challenges are still to be fully addressed for a 6G ready AI/MLOps solution, and some of these are the adoption of AI as a service approach for new monetization opportunities on top of AI/ML capabilities, the federation across multiple providers for AI/ML models and services, and also to address and even more address sustainability as an imperative aspect to align with the broader European Commission directives and goals. So thanks a lot for your attention. I leave you here my contacts, and so feel free to reach out to me.